Hey there. We are in lesson 8 today. Chapter 1, lesson 8. Lesson 8's title is Use the Quadratic Formula and the Discriminant. The discriminant is a certain part about the quadratic formula. Notice I'm using the word formula, not equation. The quadratic equation is in the form ax squared plus bx plus c equals 0. That's a quadratic equation. Quadratic formula is y equals ax squared plus bx plus c, and if I'm trying to solve, well, that's still 0, sorry. If I'm trying to solve for x, I have a formula that works, negative b, etc., etc. It's actually right there, okay? So when I use the term quadratic formula, it's a formula to figure out what these zeros or the roots or the solutions of a quadratic equation are, okay? Previously, you solved quadratic equations by completing the square for each equation separately. By completing the square once for the general equation ax squared plus bx plus c equals 0, you can develop a formula that gives the solutions of any quadratic equation. The formula for solution is called a quadratic formula. So the quadratic formula, when things are in standard form, we grab the a, b, and c parts of the quadratic equation and we plug them into the quadratic formula. And when I solve this, it actually gives the solutions of the quadratic formula. It gives us two solutions, which is where it crosses the x-axis, which is the solutions, the zeros, or the roots of the equation, okay? Oops, I see a mistake. I thought I fixed all these. So here we're solving an equation with two real solutions. So if I put this in standard form, I'm actually going to subtract 2 from both sides. X squared plus 3x minus 2 equals 0. So we know a equals 1, b equals 3, c equals negative 2. If we put it into the quadratic formula, I know that x equals plus or minus b, sorry, not plus or minus. I knew there was something wrong there. Negative b plus or minus the square root of b squared minus 4 times a times c. That is not c. All over 2 times a. So I just put everything into the quadratic formula. Let's simplify it a little bit. Negative 3 plus or minus 9 plus 8 all over 2. So negative 3 plus or minus 9 plus 8 is 17 all over 2. And at that point, we're done. The solutions to this equation are x equals negative 3 plus root 17 over 2 or negative 3 minus root 17 over 2. Okay, two solutions because a quadratic equation always crosses the x-axis at two spots, somewhere along the x-axis. And here we have the two spots. Notice big old decimals because we have radicals in our answers. If you grabbed your calculator and did negative 3 plus root 17 over 2, it'd give you a decimal. Negative 3 minus root 17 over 2, it would give you a decimal, which you see when you would graph them either in Desmos or on your calculator. Oh, I thought I fixed all these. Okay, let's ignore that. So solve an equation with one real solution. I think example 1 was 2 real solutions, so 1 real solution. Okay, we're going to see a pattern here. If I put that in standard form, I'm going to subtract 12x from both sides and add 9 to both sides. So that gives me 25x squared, negative 18 and negative 12, 8, 9, 10, negative 30x plus 9 equals 0. So we know a equals 25, B equals negative 30, and C equals 9. So my answer is going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's simplify. Negative 30 is 30. Negative 30 squared is, oh, that's an easy one, silly me, 900, duh. 4 times 25 is 100, times 9 is 900, all over 2 times 25, which is 50. 900 minus 900 is 0, so we get an answer of 30 over 50, or just plain old 3/5. So we saw one real solution because under the radical was 0. Okay, let's back up. Here we saw under the radical was a number, a real number. Okay, it was 17. Here under the radical was 0, and we only have one answer. So if you graphed it, which you'll see right here, we just have a touch on the x-axis. Pretty cool, huh? And then our example 3 is solve an equation with imaginary solutions. When we talked about imaginary things, we had I, and we know that I is the square root of negative 1. So I have an idea that underneath the radical is going to be a negative number. Let's try. Again, I'm not in standard form. Let's fix this. I'm going to subtract 5 from both sides. I have negative x squared minus 4x minus 5 equals 0. A is negative 1, B is negative 4, and C is negative 5. Let's go ahead and use our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Negative 4 is 4. I have 16 minus 4 times negative 1. I have a negative 4, negative, that's a positive 4, and negative 5 is a negative 20. All over negative 2. 4 plus or minus square root of negative 4 all over negative 2. Sorry. That gives me a negative, square root of negative 4 is the same as 2i all over negative 2. I can actually simplify this to, let's see if I can get a little more space. Yep. Negative 4 over, nope. That 4 is not negative. Sorry. 4 over negative 2 plus or minus 2i over negative 2, which equals, this simplifies to negative 2. This simplifies to negative 1. We have an imaginary answer, okay? And with an imaginary answer, our graph looks a little bit funny. It actually doesn't cross the x-axis, which we see right here. Okay, this problem actually has a leading negative, so we know it's an unhappy parabola. We know it's going to open down, and it does, and it never crosses the x-axis. So underneath our radical, when we are negative, we don't cross the x-axis. When we're positive, we cross the x-axis somehow. And then when we're 0, oops, oh gosh. Not my pen again. Oh, it's still pushed? No. Oh my gosh. I don't even know how to finish that. That's awesome. When we're 0, we just touch the x-axis. That's a mess. I don't even know what to do with that. I apologize. And here I've been making fun of my college professor for so long. It's terrible. It's really terrible. I think I got rid of it all. All right, so negative, we don't touch the x-axis. Positive, we touch it twice. And 0, we touch it once. All right, I'm going to give you the answers to these because I want to get to the next spot, which is pretty important. We're going to talk about the discriminant. So here I have, we're still erasing, x squared. I'm going to subtract 6x from both sides and add 4 to both sides. A is 1, B is -6, C is 4. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals 6 plus or minus the square root of 36 minus 16, which is 20, all over 2. And that all simplifies to 6 plus or minus, I just wrote that again, $20 is the same as 4 times 5, which is the same as 2 root 5. So it gives me 6 plus or minus 2 root 5 over 2, which I can simplify. 6 over 2 is 3. So I have an answer. That means I have 2 solutions because I have a positive underneath the radical, so it's going to cross the x-axis at 2 spots. I said I wasn't going to do these, but we'll do a few more. Subtract 2x from both sides and add 9 to both sides. A is 4, B is -12, and C is 9. So x equals -b plus or minus b squared, -12 squared, 124, 144, out of practice, minus 4 times a times c. So 4 times a times c, all over 2a. That simplifies to 12 plus or minus 144 minus 4 times a times c is 144. Shocker, I know. All over 2a. So that's 0. I get an answer of 12 over 8, which simplifies to, let's divide both by 2, 6 over 4, which simplifies to 3 over 2. So that means I only have one solution. Oof, that was bad. At 1.5. Because underneath the radical was 0. Whew, last example, and I think, so let's get this in standard form. Let's see, that gives me a -5x. 7 minus 2 is 5. That's squared. And then -4, -3 is -7. A is -5, B is 5, C is -7. Let's put it into the quadratic formula. -b plus or minus b squared minus 4 times a times c, all over 2a. So -5 let's see, 25. If I have -4 times -5 is +20, times -7 is -140. Let's see, let's just double check. -4 times -5 times -7. That was an 8. Yep, -140. So 25 minus 140 is -115. So I have -5 plus or minus the square root of -115 all over -10. So I only have one solution. Let's see if we can simplify it. I'm out of space, so I'm going this way. -5 over -10 plus or minus 115. I'm going to try to divide by some perfect squares. Divide by 9, no. 25, no. 16 certainly isn't going to be it. We're on number 3. Sorry. Nope, doesn't come out. So we'll take the negative out. Make it I square root 115 over -10. So that actually doesn't help. So we're going to keep our answer as a -5 plus or minus I 115 over -10. And just leave it as that. We can actually do this. Okay? Oof. That was tough. And we're taking a break for part A. Has my head been cut off this whole time? That's sort of sad. Part B is coming soon.